Hi, welcome to NumPy Tutorial Series. In this video, we continue exploring comparison operations. You already know how to use less, greater, equals, and other similar functions. If you missed part 1 of this lesson, please check the link in description below. But before we start, please subscribe to Badgers the Teacher and never miss our educational videos. Count non-zero function, as you might have already guessed, returns how many elements of the array are non-zeros. In this example, there are 3 non-zero values in the array, 1, 2, and 1.
It's not difficult for now, as it is quite intuitive behavior for a function with such name. However, what happens in the next 2 lines?
First, the expression in parentheses is executed. Array is equals to 1. This returns an array with 2 true values, as there are 2 elements that are equal to 1 in this array. Next, count non-zero counts how many true values are there in the result of operation in the parentheses. The result, that's why, is 2.
Oh, interesting. Let me try the second example, it looks very similar. First, we check whether each element of the array is greater than 1. This returns array with 1 true value, because there is only one element that is greater than 1, it is 2. Then, count non-zero outputs 1, because it counts true values in the result of the previous operation.
You nailed it! Let's take a step forward. We can add access parameter to count non-zero function.
Is the default value of access 0, like in many other NumPy functions?
No, this time default access is equal to none, not 0, as in most cases we have seen so far. Here we try the same examples as on the previous slide, but with access equal to 0. What we see? Results are not the same as on the previous slide. As the access 0 stands for direction down the rows, while we move down, we count non-zero values for each column.
The first command thus returns an array with count of non-zero elements in each column. In the column with index 0, there is one non-zero element, which is 1. In the column with index 1, there are 2 non-zeros, 2 and 1, so the second value in array is 2.
The next example also produces an array with a result for each column, 2 ones, as both columns have ones. The last example returns 0 for the first column, as there is no element that is greater than 1 in the first column, while there is one element that is greater than 1 in the second column.
Let's change access parameter value to 1. What happens in this case?
That means we go across the columns, from left to right, this way counting non-zeros per each row.
Got it. The first example thus counts how many non-zeros are in each row. 2 in the first row and 1 in the second.
Correct. The second example compares each element to 1 and counts how many elements that are equal to 1 are in each row. The result is 1 in each row. It's exactly what we see in the table. The third example counts how many elements that are greater than 1 are there in each row. Only the first row has such element, it's 2. So the output is 1 for the first row and 0 for the second one. Take your time and practice. We will discuss some function in the lesson on universal aggregation functions. In a nutshell, it returns the sum of elements. The first line thus returns 4, because it's 1 plus 2 plus 1. In other words, the sum of array elements, nothing difficult or unusual. In the next examples, we have a combination of sum function and comparison. In this case, true is interpreted by sum function as 1 and false as 0. So, in fact, sum counts how many true values are there in the array with comparison result. First, let's output the result of the expression array is equal to 1. It's an array with 2 true values, at positions where ones are located. When we execute some function with such a comparison, we get 2, because there are 2 true values.
Not so difficult, but something to keep in mind. So in the next example, again, let's output the result of an expression array is greater than or equal to 2. Only one element matches this condition, it is 2. So the sum returns 1, because there is only one element matching the condition in parentheses, and thus only one true value.
A bit confusing, I know, so please take one step at a time, and first of all, think of condition and the array with its result. Don't try to sum up the values that are matching the condition. We will cover any and all functions in the lesson on aggregation functions as well. But let's see some examples now. The first example checks whether there is any element that is equal to 1. It outputs true.
The second example checks whether all the elements are greater than or equal to 0. The result is also true.
The third example checks whether all the elements are even. It is a modulus from the division by 2 is 0. Pay attention that again, x's default value here is none, not 0.
Let's see some examples with axis equals to 0.
If axis is 0, it means that we check the result for each column. For example, the first statement checks if there is any element in each column that is greater than or equal to 2. There is no such element in column with index 0, so result is false. There is, though, such an element for column with index 1, so output is true. I will leave remaining 2 examples for you to analyze them on your own. Please let me know in comment section how you would explain these examples. Let's leave this slide for your self-study as well. Ask your questions in comments below. I will just remind you, as axis is equal to 1, we go from left to right and get results per each row. That's it for today.
So we have covered the most important comparison operations and masking. So please study presentations of both parts of this lesson and practice with different arrays.
Please subscribe to Badger the Teacher and never miss new lessons. See you. Bye bye.